Hello everyone, hope everyone is doing well. In this video, we're going to look at why is the probability of a single number in a continuous distribution equal to 0. So which means that, let's say if I'm looking at a normal distribution or any other distribution, let's say like a uniform distribution or any other kind of continuous distribution, the probability that x is equal to a certain number, let's say x, or let's say the probability the number is any value, is always going to be 0. And so in this video, we're going to see why that is the case. So before we delve into that, we should look into discrete distributions first. Let's start with a small discrete distribution. Let's say we have a dice with 6 sides. Each side, it has 1, 2, 3, 4, 5, 6. And the probability of each number happening is 1 over 6 or 0.16. So the probability of getting a 4 is 0.16, probability of getting a 6 is 0.16. So it's a fair dice and they all have equal probability of happening. Now let's say we have a dice that has 12 sides. So it goes 1, each side, one side has 1, one side has 1.5, 2, 2.5, 3, and so forth. In this case, and if it's a fair dice, the probability of each number happening, or if I roll the dice, the probability of getting a 1 is going to be 1 over 12 or 0.08. So the probability of getting a 3 is also going to be 1 over 12. So if you notice the difference between these two probability distributions, as I increase the number of observations within the discrete distribution, the probability gets smaller. So now we can actually now we can generalize this idea a little more. As we can see, if we increase the numbers in a discrete distribution, so let's say a dice had 6 sides, 12 sides, then 20 sides, then 100 sides, and then 1,000 sides. So we keep on adding more and more numbers within that discrete distribution. If it's a fair dice, then we can see that the probability of getting a specific number keeps on falling. So it's 1/6, then it goes to 1/12, then 1/20th, 100th, and 1,000. So I can add another number. Let's say I have 10,000 numbers in my discrete distribution. And the probability of getting each of those numbers is going to be even smaller. So this then tells us that we have an inverse relationship between the numbers that we have in a discrete distribution and the probability. As the numbers increase, the probabilities decrease. So now let's go to a continuous distribution. If I have a normal distribution, so let's just take a standard normal distribution. Let's say we're going from 1 and -1. So between these two numbers, how many numbers are there if it's a continuous distribution? So the numbers between these two, the total number is going to be infinite. There's going to be an infinitely number of numbers between 1 and -1, or 0 and 1. One easy way of seeing it, if I have these two numbers, how many numbers are between them? Well, okay, let's find a number in between those two numbers. So a number in between -1 and -1 is going to be 0. Now I have 1 and 0. Is there a number in between those two numbers? Yes, I can write it's 0.5. Okay, so that makes sense. So let's take a number between let's take 0.5 and 0. Is there a number in between that? Yes, it's 0.25. So if I keep on taking any two numbers, let's say even if I take 0.5 and 0.051, can I find a number that's in between these two numbers? And I can easily find it. I can say equals to this number plus this number divided by 2. So I get 0.505. Now 0.505 is, again, a different number from 0.5051. So then we can see that no matter what two numbers we have, we can always put more numbers in between. Therefore, for a continuous distribution, if I know the ends, I know that there's going to be an infinite number of numbers between those two ends. If it's a normal distribution, it doesn't have an end. It goes from -infinity to +infinity. So we can see that it will always have an infinite number of numbers in between those two ends. So as a result, we can see that if I keep on adding even larger and larger numbers, so I can write in a continuous distribution, therefore, the probability of each number is so small, it is basically 0. Now, although the probability of a specific number in a continuous distribution equals to 0, we can nonetheless find the probability for a range of numbers. For example, in this case, let's say probability that x equals to a specific number like x equals 3 is 0 in a continuous distribution, let's say. But we can find for a certain range like x between 3 and 4, the probability that x is between those two numbers. We can now calculate that probability. Hopefully this was helpful, and I will see you at a later video. Have a good day. Goodbye.